Dark matter, the elusive substance making up over 80% of the universe's material, remains one of the greatest mysteries in astrophysics. Its antisocial nature, refusing to interact with light and normal matter, renders it effectively invisible. But could dark matter interact with itself? New research suggests using galaxy clusters as natural dark matter colliders might help answer this question. Galaxy clusters, dominated by dark matter, provide a unique opportunity. Jacqueline McCleary, assistant professor of physics at Northeastern University, explains, 80 to 90% of their mass is dark matter, and the more massive an object is, the faster the constituent dark matter particles will be moving. You're essentially studying very high-energy collisions. If dark matter particles do self-interact, perhaps by colliding or even annihilating each other, examining cosmic crash sites where galaxy clusters collide could reveal these interactions. While this wouldn't identify the exact particles making up dark matter, it could eliminate models that don't allow for self-interaction, bringing scientists closer to understanding dark matter. The lack of interaction is what makes dark matter so challenging to study. Despite its significant gravitational influence preventing galaxies from flying apart, dark matter doesn't interact with light. This ghost-like behavior means dark matter isn't composed of familiar atomic particles like electrons, protons, and neutrons. Thus, the hunt for a suitable dark matter particle is on. Candidates range from weakly interacting massive particles, WIMPs, and massive compact halo objects, MACHOs, to tiny particles like axions or sterile neutrinos. Even primordial black holes from the Big Bang have been proposed. However, all these suspects have so far defied detection, keeping them in the realm of theory. Unlike normal matter, dark matter can't be loaded into a particle accelerator like the Large Hadron Collider, LHC, for study. Instead, scientists infer its presence through its gravitational influence. Dark matter warps spacetime, telling light and matter how to move, revealing its presence around galaxies and in the cosmic web that helps galaxies grow. McCleary and her team suggest that galaxy cluster collisions could act as natural dark matter colliders. If these clusters collide with enough force, dark matter interactions might occur. These could range from particles bouncing off each other to mutual annihilation, releasing energy. Some dark matter models propose that dark matter could be its own antiparticle, leading to self-annihilation upon collision. To test this idea, researchers created computer simulations of galaxy cluster collisions, incorporating physical models of interactions between stars, gas, and dark matter. These simulations could guide real-world observations of dark matter collisions, helping scientists determine the characteristics of dark matter particles and narrow down potential candidates. By studying multiple merging galaxy clusters, scientists hope to measure dark matter self-interaction. McCleary emphasizes, if you can measure some self-interaction, or if you can place some upper limit, you are ruling out or ruling in classes of particles that dark matter could be. This process of elimination, although indirect, brings researchers closer to unveiling the true nature of dark matter. The team's findings were published in the journal Monthly Notices of the Royal Astronomical Society, advancing our quest to understand the universe's most mysterious component. Subscribe for more videos like this. See you in next video.